Hello, I'm Yongsin. We are from USM School of Chemical Engineering, EKC 216 Group 5. In this video, we are going to present to you the design of heat exchanger. First, what is heat exchanger? Well, Divya, can you briefly explain what is heat exchanger?
Yes, Yongsin. A heat exchanger is usually denoted as HEX. A heat exchanger is a device that used to exchange heat between a hot fluid and a cold fluid. The main intention of designing a heat exchanger is to heat a cold fluid or to cool a hot fluid. The fluid in the heat exchanger are not allowed to mix. This means that the fluid will be flowing in separate channels which are bounded by walls to prevent mixing. As you all know, the application of heat exchanger is considered as wide because it used in our daily basis and also in industries such as in refrigerator, aircraft, automobile and in chemical processing. The heat transfer rate is calculated by using the combination of convection in fluid and conduction to the wall. Therefore, we cannot calculate the heat transfer rate by using a single parameter like thermal conductivity instead of using overall heat transfer coefficient to describe the combined effect of conduction and convection in the heat exchanger. In our plant design, there is totally 6 heat exchanger and we were assigned with H104. H104 is named as splitter preheater and it is considered as steam condenser as condensation process is occurred in the shell. The liquid mixture that consists of propane, propylene and hydrogen is passed through the tube at 30 bar and 25 degrees Celsius, whereas steam passed through the shell at 3 bar and its saturation temperature of 133.52 degrees Celsius. Thank you. Liana, can you explain about the process condition of the heat exchanger?
Thank you, Divya. For process condition, the assumptions may include no heat loss to surrounding and no volume resistance occur. Next, the properties of propane will be used for any fluid in the stream. Since heat of radiation has a very minimal effect on the heat exchanger, it will not be considered in our design. We also assume that the flow is fully developed in the heat exchanger. Next, the film condensation heat transfer coefficient is used in the steam. The condensate drains smoothly from the tubes above to the ones below. The fluid-specific heat do not vary with temperature. And lastly, convection heat transfer coefficient is constant along the heat exchanger. For design condition, we assume the type of heat exchanger involved is the shell and tube heat exchanger. For the material, we assume a standard steel of 1 inch, Schedule 40 as suggested by our reference. Next, the ratio of length of the tube to the diameter of shell must be in between 5 to 10. We also assume a square pitch and 10 by 10 square array design is used, which is convenient to calculate the number of tubes in one tier. Next, we assume a horizontal and countercurrent tube flow. The correction factor will be 1 because the process involved in this project is condensation. Lastly, we assume a fixed and U-tube headings is involved. Based on our calculation, we obtain that the most suitable heat exchanger is the shell and tube heat exchanger with rate of heat transfer of approximately 10 million kJ per hour. Also, we have determined the area of the heat exchanger, which is 28.4568 meters squared. Next, there will be a total of 1 number of shell pass, 1 number of tube pass and 86 number of tube per pass. Yongsin, can you please justify the results that we get? Thank you.
Thank you, Divya and Liana, for the explanation. In order to justify the answer, first we need to calculate the heat transfer from steam to streamline. At heat exchanger, there is no work done. Thus, the relationship between enthalpy and heat is equal. So, we get the heat absorbed by the stream, then we calculate the LMTD. But first, what is LMTD? LMTD is log mean temperature difference, which is the temperature difference at one end between heat exchanger and stream with the other end divided by natural log of the ratio of these two temperature difference. In order to calculate the area of heat transfer, overall heat transfer coefficient must be known first. Thus, the assumption was made is U equal to 1000 and we can calculate the area of heat transfer. Here is a fact about areas. For conduction, heat transfer will almost always be directly proportional to the area. While for convection, the heat transfer is a complicated function of the fluid mechanics problem, which is the function of both geometrical configuration of heated surface and the thermal and viscous fluid property of the convecting medium. However, we have to verify the overall heat transfer by calculate manually the condensation, conduction, and convection heat transfer coefficient. If the calculated overall heat transfer coefficient has a large difference with the assumed value, iteration need to be done from assumed U, find the area, and verify U, until both value has the small difference. In real heat exchanger design case, more factors need to be considered, such as Tubular Exchange Manufacturer Association TEMA standard, pressure drop, cost of construction, heat to surrounding, and etc. However, as to fulfill the learning outcome of process heat transfer, we need to focus on the fundamental heat transfer only. That's all for our presentation.
Thank you.
Thank you.